Welcome to our channel. Today, we're diving into some of the most fascinating and extreme planetary phenomena in the universe. We're talking about worlds so bizarre, so alien, they make science fiction look like a walk in the park. Get ready to explore planets where the atmosphere is constantly being blasted away, where ice and fire coexist, and where you could spend a year in daylight and a year in darkness. Let's get started. Imagine a planet so close to its star that its very atmosphere is at risk. The proximity to such a powerful celestial body means that the planet is constantly exposed to extreme conditions. The gravitational pull alone would be immense, but the real danger lies in the star's emissions. We're not just talking about a little wind here. These are intense stellar winds, streams of charged particles that can travel at incredible speeds, sometimes reaching millions of miles per hour. We're talking about intense stellar winds, a relentless barrage of charged particles and powerful radiation that can literally strip a planet bare. These winds are not just a gentle breeze, they are a force of nature that can erode a planet's atmosphere over time. Think of it like this. Our sun, a pretty average star, constantly emits a stream of charged particles called the solar wind. This solar wind is a continuous flow of charged particles, primarily electrons and protons that emanate from the sun's outer layers. This wind, even at Earth's distance, can buffet our magnetic field and create those beautiful auroras. The Earth's magnetic field acts as a shield, protecting us from the full brunt of the solar wind, but even so, we can see its effects in the form of stunning light displays in the polar regions. Now picture a planet much closer to its star, say, orbiting a red dwarf, the most common type of star in the Milky Way. Red dwarfs are smaller and cooler than our sun, but they are far more numerous, making up about 70% of all stars in our galaxy. These stars are cooler than our sun, but don't let that fool you. Despite their lower temperatures, red dwarfs can be incredibly active, with frequent and powerful stellar flares. They can unleash powerful flares, sudden bursts of energy that dwarf anything our sun can muster. These flares can release a tremendous amount of energy, sometimes equivalent to billions of atomic bombs going off simultaneously. A planet in such a system, especially a gas giant like a hot Jupiter, would be subjected to these intense stellar winds and flares. Hot Jupiters are gas giants that orbit very close to their stars, often within just a few million miles. The heat alone would be enough to puff up its atmosphere, making it more susceptible to being stripped away. The intense heat from the nearby star causes the planet's atmosphere to expand and become more tenuous, making it easier for the stellar winds to erode it. Over time, this constant bombardment can actually strip away a planet's atmosphere, leaving behind a barren core. The process is gradual but relentless, and over millions of years a once vibrant planet can be reduced to a lifeless husk. It's a cosmic case of planetary erosion, a stark reminder of the power of a star. The forces at play in the universe are immense, and the delicate balance that allows a planet to retain its atmosphere can be easily disrupted by the star it orbits. Could a planet exist with a surface of ice but a heart of fire? This question might seem like a paradox, but in the vast expanse of the universe, such contradictions are not only possible but might be more common than we think. It sounds like something out of a fantasy novel, but the universe is full of surprises. The cosmos is a place where the unimaginable becomes reality, and the boundaries of what we consider possible are constantly being pushed. Let's imagine a planet tidally locked to its star, meaning one side always faces the star, bathed in perpetual daylight, while the other side remains in eternal darkness. This unique configuration creates a world of extremes, where the environment on one side is drastically different from the other. The day side would be scorching hot, hot enough to melt rock and create vast lava flows. The intense heat would make the surface resemble a molten landscape, with rivers of lava flowing across the terrain, creating a hellish environment. But the night side, locked in a perpetual freeze, would be a very different story. Here, the absence of the star's warmth would plunge temperatures to unimaginable lows, creating a frozen wasteland. Here, temperatures would plummet, causing any atmospheric water vapor to freeze and fall as snow, creating massive ice sheets. The landscape would be dominated by ice and snow, a stark contrast to the fiery day side. Now, imagine if this planet had a lot of internal heat, perhaps from radioactive decay in its core or tidal forces from its star. This internal heat could create a dynamic environment beneath the surface where the heat from the core interacts with the icy exterior. This internal heat could melt the ice from below, creating a subsurface ocean sandwiched between the ice above and the molten rock below. This hidden ocean could be a haven for life, protected from the extreme conditions on the surface. This bizarre world would be a planet of stark contrasts, a place where ice and fire coexist, separated by a thin veneer of liquid water. The juxtaposition of these extreme environments would create a unique and fascinating world. It's a testament to the incredible diversity of planetary environments that might exist out there. The universe is a place of endless possibilities, where even the most unlikely scenarios can become reality. This planetary paradox challenges our understanding of what a planet can be, reminding us that the cosmos is full of wonders waiting to be discovered. We take for granted the cycle of day and night here on Earth. The sun rises, bringing warmth and light, and then sets, giving way to the cool, dark night. This rhythm is so ingrained in our lives that we rarely stop to think about it. But imagine a planet where the sun never sets on one side and never rises on the other. A world where one hemisphere is perpetually bathed in sunlight while the other is cloaked in eternal darkness. This is the reality for tidally locked planets, worlds that rotate at the same rate they orbit their star. This synchronous rotation means that one side always faces the star, while the other side is in constant shadow. One side of these planets is in perpetual daylight, basking in the constant glare of their sun. The surface here would be incredibly hot, with temperatures soaring to extremes that we can scarcely imagine. The other side is shrouded in eternal night, a realm of perpetual darkness. Here, the temperatures would plummet, creating a frigid, icy landscape. But what would it be like to live on such a world? How would life adapt to these extreme conditions? On the day side, life would have to adapt to the constant sunlight. Plants might develop unique ways to regulate their temperature, perhaps evolving reflective surfaces or specialized cooling mechanisms to prevent overheating. Plants might develop unique ways to regulate their temperature, using reflective surfaces to bounce back the intense sunlight, or developing deep root systems to access cooler soil layers. Animals might be active only during certain times of the day, seeking shade when the sun is at its zenith. They could evolve behaviors and physical adaptations to cope with the relentless heat, such as burrowing underground or developing heat-resistant exoskeletons. The night side, however, would be a much more challenging environment. The absence of sunlight would mean a lack of warmth and energy, making it a harsh and unforgiving place for life to thrive. Without sunlight, there would be no photosynthesis, the process by which plants convert sunlight into energy. This would make it difficult for traditional plant life to survive. Life here would have to rely on alternative energy sources, perhaps chemosynthesis, using energy from chemical reactions. This process is seen on Earth in deep-sea hydrothermal vent communities where life thrives without sunlight. The boundary between these two extremes, the terminator, would be a region of perpetual twilight. This narrow strip of land caught between the blazing day and the freezing night would have a unique set of conditions, a place where the temperature gradients would be extreme, with rapid shifts from hot to cold. This could create a dynamic and potentially habitable environment where life might find a delicate balance. It's possible that this region, with its unique conditions, could harbor the most diverse life on a tidally locked planet. The constant twilight might provide a stable environment for a variety of organisms, each adapted to the specific challenges of this in-between world. We've all grown up with the image of a single sun in the sky. But what if you lived on a planet with two suns? It sounds like science fiction, but these circumbinary planets, worlds that orbit two stars, are a real phenomenon. Imagine a binary star system, two stars locked in a gravitational dance around their common center of mass. Now picture a planet orbiting this stellar duo, not one star but both. This planet's orbit wouldn't be a simple circle, but a complex, winding path influenced by the gravity of both stars. The view from this planet would be breathtaking. Imagine two suns in the sky, sometimes close together, sometimes far apart, casting intricate shadows and creating a constantly shifting tapestry of light and color. The length of day and night would be unpredictable, varying depending on the planet's position relative to its two suns, and the sunsets. Imagine two suns dipping below the horizon, painting the sky in a kaleidoscope of hues. It would be a sight unlike anything we experience here on Earth. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more amazing content. We've only just scratched the surface of the weird and wonderful world of planetary phenomena. There are countless other cosmic wonders out there, waiting to be discovered. So keep exploring, keep asking questions, and keep your sense of wonder alive. See you next time.